Number 1. You decide to play Mario Kart on the Nintendo 64 and foolishly challenge Rainbow Road. Early into the race, you fall off the map for 7 seconds as you fall a total of 25 feet before being carried back to the colorful road of death. What was your acceleration when you fell? For number 1, the given variables are the time and the distance, 7 seconds and 25 feet. I used the equation of x equals 1/2 at squared, and then I plugged in both the time and the distance for x, and then I solved it to get that the acceleration is 1.02 feet times or divided by seconds squared is equal to the acceleration. For number 2, a toy car is traveling a velocity of 5 feet per 2 seconds and needs to make a 12-foot jump. If the toy travels for 4 seconds, will it make the jump? If not, by how much did it miss? If so, by how much did it make it? For number 2, the given variables are the velocity and time. The velocity was 5 feet per 2 seconds, but to simplify that, I made it 2.5 feet per second. The time is equal to 4 seconds. The distance is I used the distance equals velocity times time formula to find out the distance that the car travels. I substituted this for velocity and then this for time to find out that the distance traveled by the car would be 10 feet. And the problem was asking if it would make the 12-foot jump. So no, it would not make the jump, and it would miss it by 2 feet by subtracting 12 feet and 10 feet. For number 3, Alyssa made a bet with Rahul that he can't swim underwater without a breath of air as far as she can, and lost. If Alyssa and Rahul both swam with a constant velocity of 4 feet per second, by how much in meters did Rahul beat Alyssa if Rahul held his breath for 20 seconds while Alyssa held hers for 17 seconds? For number 3, I used A for Alyssa, R for Rahul. Their times are different as hers is 17 seconds and his is 20 seconds. The velocities were given as the same. For both Alyssa and Rahul, I used the equation x equals velocity times time to find the distance traveled, which would be, I used her variables to get 68 feet. Then I converted the feet into meters as the question is answered in meters to get 20.7 meters. Rahul, I did the same thing. I got the variables that he has. I plugged them in to find out that his is 80 feet. And then I converted that 80 feet into meters, 24.4 meters. And then to find how much Rahul beat Alyssa, I got Rahul's meters and Alyssa's traveled meters and subtracted to find out that Rahul beat Alyssa by 3.7 meters. For number 4, we're using the scale of 1 inch is equal to 2 newtons. The Grand Blanc High School male teachers are going against the Grand Blanc High School male seniors in a tug-of-war match. At the start, the teachers pull on one side 9 inches in vector form, and the seniors pull on the opposite side with 13 inches in vector form. What is the least amount of force needed to be added for the teachers to beat the seniors? Draw vectors if needed. For number 4, forgive me for a second. Number 4, right here. I use the given scale to find, and then I have teachers for T, students for S. The teachers had 9 inches in vector form, so I multiplied that by 2 to find the newtons, and then the same thing for the students. I got the students' newtons, subtracted the teachers' newtons to find out that to make an equilibrium, it will be 8 newtons, but the question is asking how much the teachers need to win. So I added 1 newton to find out that the teachers need 9 newtons more to beat the seniors. For number 5, in a baseball game, a ball is hit 4 meters above the ground, straight into the air. If the maximum height reached was 21 meters, how long will it take the ball to hit the ground? For number 5, the given variables are x and a, the acceleration. The distance is 25 meters because the ball was hit at 4 meters above the ground, and then the peak was 21. So I added these two because it's asking from the peak to the ground, so that will be 25 meters. The acceleration as it's falling down is gravity, so negative 9.8 meters per second squared. And then I took away the negative here because with time it does not really matter whether I have negative 9.8 or positive 9.8. So I used the equation of x equals 1/2 at squared. I plugged in both the respective variables to find out, and then I solved for the time to find out that the time from the peak to the ground would be 2.3 seconds. For number 6, a box with a mass of 5 kilograms is pushed for 12 seconds for a distance of 9 meters. Find the acceleration. What's given in number 6 is the mass, 5 kilograms, though it's irrelevant right now. The time is 12 seconds, and the distance traveled was 9 meters. I used the equation x equals 1/2 at squared. I plugged in 9 meters for x, time 12 seconds, and I solved for the acceleration to find out that the acceleration is 0.125 meters per second squared. For number 7, using the two boxes both identical to the one in number 6, this is when the 5 kilograms is needed. Find the amount of force used in newtons if the acceleration was half of number 6. For number 7, I used the equation F equals MMA, and then the mass is 10 kilograms because the given weight was 5 kilograms for the box, and now we need double of that. So now 10 kilograms, the acceleration is 0.0625 meters because I divided this by 2 because it says half of the acceleration. So I multiplied the mass and the acceleration, as the equation states, to get 0.625 newtons. For number 8, in a tournament match between MSU water polo and U of M water polo, MSU made a full lob shot for the win. If its peak was 14 feet high and the time in the air was 6 seconds, what was the acceleration of the ball coming down into the net? For number 8, the given variables are the distance and the time. Time was 6 seconds and the distance was 14 feet, but it's asking the acceleration when it's coming down, so that's only half of what it's traveled. So I divide by 2 to get 7 feet. I use the equation x equals 1/2 at squared. I plugged in the variables to find out that the acceleration of the ball coming down would be x equals 4 feet, or a equals 0.4 feet divided by a second squared. For number 9, in the U of M versus OSU game in 2013, an OSU player started to throw punches and started a fight. After being sent to the locker room, he threw his helmet a distance of 10 feet in a time span of 4 seconds. What was the velocity of the helmet thrown as he told everyone that he's number 1? Okay, for number 9, the given variables are the distance, which is x, 10 feet, and time, 4 seconds. I used the distance equals velocity times time. I plugged in the 10 feet and the time, or not the time, the time, and then I divided in order to get the velocity, which is 2.5 feet per second. Now for number 10, Grant Fisher meets the Flash and wants to race him. If Grant and the Flash both traveled for 20 seconds, by how much feet did Grant beat the Flash if he traveled 27 feet per second squared and the Flash only traveled 23 feet per second squared? For number 10, I used G for Grant, F for Flash. I given them their respective variables. The time for both is the same, and the acceleration is different, as given. I used the equation x equals 1/2 at squared to find out the distance traveled by Grant and the Flash, to find out that Grant traveled 5,400 feet and Flash 4,600 feet. To find how much Grant beat the Flash, I got Grant's feet and the Flash's distance traveled, and subtracted that to find out that Grant beat the Flash by 800 feet. For number 11, a ball is rolling down a hill with a constant acceleration of 1.5 feet per second squared. How far and fast is it going after a total of 4 seconds? For number 11, the given variables are the acceleration and the time. Acceleration is 1.5 feet per second squared. The time is 4 seconds. I used the equation velocity is equal to acceleration times time to find out that the velocity would be 6 feet per second squared when plugging in these variables. And then the question asked to find how far it traveled. So I used the distance formula, x equals velocity times time, and then I plugged the 6 feet per second for the velocity found, and then the 4 seconds given time to find out that the distance traveled was 24 meters. For number 12, a tow truck accelerates at 8 meters per second squared. Coincidentally, a tow truck exactly like this one from the same company was totaled and needed the working tow truck. What would be the acceleration of the tow truck now? For number 12, the given variable is the acceleration of the tow truck, which is 8 meters per second squared. The acceleration would be divided by 2 because the tow truck is carrying its mass, once again, double that. So you divide the acceleration by 2 as it's going to be slower. So I got the acceleration divided by 2 to find out that the acceleration is 4 meters per second squared. For 13, in order to move his non-working car off the train tracks, Jake and many helpful bystanders must push 20 kilograms at 3 meters per second squared. How much force was needed if there was a frictional force of 270 newtons? For number 13, I used the equation F equals MMA of A. The frictional force was also given 270 newtons. The force, which was given, or the mass, which was given, was 20 kilograms, and the acceleration, which was given, was 3 meters per second squared. I plugged those in to find 60 newtons. And that's how much force they used to push. But they also needed to overcome the frictional force of 270 newtons. So the force amount needed is really 330 newtons. For number 14, a bird saw amazing food on the kitchen table of Zaid's house. If the bird traveled 20 feet with a velocity of 1.5 feet per second, what was the time it flew before it hit the clear window? What was its acceleration? For number 14, what's given is the distance traveled and the time, 20 feet, 13 seconds. I used the distance formula to find the velocity, or to find the time. This is supposed to be velocity is equal to 1.5 feet. I'll change this later. And then I plugged in these variables to find out that the time is approximately 13 seconds. And then it's asking for the acceleration. So I use the equation of x equals 1/2 at squared. And then I plug in these variables, or this variable and the time found, into here to find out that the acceleration would be 0.24 feet per second squared. And for number 15,